vulnerabilities in the home page, the registration, sign up page, login, forgot password, provide updates. Yeah, vulnerabilities. Initially, sometime back, what we did, we have done a reconnaissance by using Lapsuit and many other tools. So without wasting time, we have time is going. The session is being recorded. It will be available after the presentation. I have no slides, but I can share the text files in the group for anyone who wanna have a look at the presentations. Well, practically, immediately this is our target. I'm fetching our target from our background. Our target for today is Unity Technology. Unity Technology is committed to the introduction to the target. So it's our target for tonight. What we're gonna do, we're gonna check the home page vulnerabilities. That's open redirect among us these vulnerabilities, social media, broken link hijacking, host header injection, SQL injection, process scripting, cross-origin source sharing, HTML injection. That's on the home page. Then we have the registration or page vulnerabilities. That's why we have the HTML injection, email verification bypass, rate limiting vulnerabilities, direct object reference, SQL injections. Let's call them injection flows. Then on the login page, we have the cross-site request forgery, injection flows, rate limiting vulnerabilities, the authentication bypass. That's 2FA, MFA, and the rest. Then on the forgot password or stroke reset password functionality, we have the rate limiting vulnerability, the password link encoded in base 64. This P4 vulnerability and BugBounty. And so someone gets some bounty for this. Then we have the account takeover vulnerabilities, the injection flows. Same forgot password. I think we should add a vulnerability here, which is server-side request forgery. Yeah. So on the profile update vulnerabilities, profile update functionality, we have the following vulnerabilities. We have the cross-site request forgery. We have IDOR, server-side request forgery, in the link addition functionality. I demonstrate this practically. We have the Tabnabbing. We have cross-site scripting. That's talking of the injection vulnerabilities. That's on the profile update functionality. So immediately, let's lean to our targets. Our target for tonight, we're gonna check all those vulnerabilities in our target, which is Unity Technology. Our email that I will use for sign up is our email. That's BugBounty@gmail.com. If we gonna need a third-party Gmail, I think I'll have another one over here on Chrome. So it's our target at background. Minimum bounty, that's for P4 is $100. A P1 goes for $3,000. That's 300K. So you can check what's in scope, what's out of scope. We have discussed this earlier on. You can get the sessions on our YouTube channel. So the rating and stuff. So, okay. The scope, in scope, out of scope, which this is a basic. You should not test an out of scope vulnerability or out of scope endpoint. You should not test that, but you can have a look at out of scope endpoints, because some vulnerabilities, such as the out vulnerabilities, can happen whereby you can create an account to the out of scope subdomain, then I use those same credentials to log in a in-scope subdomain which you initially have never created an account before. So that's a vulnerability. That's a vulnerability. So yeah, let's as an endpoint immediately sign up. Okay, let's have a look at the home page. At the back we are running BugSuite. It's a BugSuite profession version. So what I'm gonna do, let me restrict our traffic at BugSuite so that we can only have a look at unity.com endpoints. So go direct to our target scope, yeah, / here. Keyboard is what I did, yeah. So now I'm here, okay, / here. So by doing this, I think we explained the last session, but by doing this, what we get, traffic at this endpoint gonna be only restricted to unity.com. So we're gonna turn on our proxy, that's our website, and traffic our data here. So let's start the page and have a look. Yeah, exactly. So the traffic here is unity.com, components.unity.com, store.unity.com. Yeah, at this same page, you're gonna check for search functionalities. You're gonna test for cross-site scripting here using different payloads. And you try. I'm gonna use basic payloads. That's a script. That one. Yeah. So you're gonna test for injection flows. You're gonna test for process scripting, for SQL injection, for other injection flows, HTML injection. Yeah, we're gonna test. You're gonna test for HTML injection. Let's say it's a payload for process scripting. So again, we're gonna test for HTML injection. Let's say Astana 254 H1. That's it. So let's test for HTML injection. There's no crime for testing. Okay. So there's no HTML injection at our endpoint. We're gonna test for SQL injection, for cross-site scripting as well as we have tried before. Then you're gonna have a look at other endpoints, juicy endpoints that are gonna give you some scope for testing at this homepage endpoint. So we can have a look immediately. Let's scroll down. Answer blogs. So we can open the blog, increase our scope. Maybe you can get an endpoint to test for store cross-site scripting. Let's click having a look. So nothing juicy at the moment. Okay, down here we have the chat box. We call it the support assistance, maybe live assistant and stuff. So at this point, you can test for WebSocket vulnerabilities. You can by proxying your traffic, you can check if this endpoint has cross-site request forgery tokens. If it lacks cross-site request forgery tokens, then you can go ahead and test for cross-site WebSocket hijacking vulnerability. At the same time, you can test for injection flows at this endpoint. That's a SQL injection, cross-site scripting, amongst many other vulnerabilities. You can test for cross-origin source sharing, which you can chain as time goes by. So going back to our domain, so our domain back home page. What are we doing here? We are at the home page. Yeah? Let's start with open a redirect. Assuming that it's like this. Okay, let me search for something. I'm trying to get an endpoint for open redirect solutions. Nothing juicy. Nothing juicy. Let's check for search stats. Let's search for one. Anything interesting here? For all the vulnerabilities that you can see. Okay, assuming that our endpoint is this equals to ID, let's say ID equals to 1. Yeah, so at this particular endpoint, maybe equals to 1. Okay, you can test for redirection, let's say google.com, you can try playing the parameter with the URL so that you can be allowed, so that you can bypass the redirection vulnerability. It's a P4. Some vulnerability, some programs range it as a P4, others as a P5. So depending on the impact, we are still on the home page endpoint testing for vulnerabilities. We are about to sign up. So our next up vulnerabilities, social media broken link hijacking. It's an interesting vulnerability. So as we know, most companies, not most, all, let's say 99%, down here you can scroll so relax. Let me get one. Check for texter immediately. There's no crime for having a look. This is how we got to test for social media broken link hijacking. Yeah, let's get one. Contact page. Yeah, exactly. Okay, I think at this point, if we had a URL on Facebook that points to Texter Technologies, when you click on the URL here, it doesn't bring you the page for Texter at Facebook. So as an attacker, you could go and craft your URL, have a similar URL that's on this endpoint, which is not live at the other pointer. And so when visitors of this company, Texter, they click the URL for Facebook, they get redirected to your page. That's a vulnerability. At the same time, okay, let's test for YouTube. Okay, it's a default. This doesn't work. Okay, that's what we call social media broken link hijacking at the home page. Another vulnerability that we're gonna have a look at is post header injection. Okay, at the home page, it's a home page. Let's start our home page. Then we are trafficking our traffic using BugBounty proxy. You can go back to our history, select this one. Okay, you can select your particular endpoint. I don't mean the home page particularly. We have different endpoints that have been intercepted over here. But for our case, let's check this one. Send the repeater. And the repeater, you can send and check for the response. Let's check the time. Okay, maybe let's delete this key sample sessions. Interesting. So let's add this one. Let's test repeater. Send it. It's taking time, huh? Let's keep explaining this. Okay, host header injection. You inject your host here. Maybe let's come and inject evo.com. Then you send. Host header injection can be changed to different vulnerabilities. Host header injection itself is a P4, it can be a P3 depending the program. So it can have an impact of open redirect. So that's a change from host header injection to open redirect. Amongst many other vulnerabilities, I don't know why. But, okay, not bad. Let's keep having a look at this because I need my traffic isn't going through. Yeah, there is. So let's test for host header injection. Assuming this is a home page endpoint. So immediately people.com, you can test using your UC URL. So people.com is a bad request. You can try by passing by simple techniques, maybe www.evo.com. It's a bad request, and many other endpoints. So at this particular endpoint, host header injection is tested using this particular point. Assuming that you have tested for people.com host header injection, you got a 403 forbidden. You can try by passing your host header. You have the 403 here forwarded for 127.1. Okay, it's up 0.1. Yeah, so you can try by passing the 403 error. At the same time, if it still persists, you can try moving the zeros. Here's called our bypass, firewall bypass. Gets a 200, that's okay for you. You're gonna earn your bounty simply that way. Simple, okay. What I'm trying to demonstrate is that simple techniques give you bypasses. Simple techniques earn you bounties. Our next vulnerability on our home page is SQL injection in the search functionality. At this point, what is that? Our search functionality. Let's save some time. Save some time. Okay, it's our search functionality. Let's try whether we can get its endpoint by search something. Doesn't come. Okay, but at some programs, let's say you have searched for 1, 2, 3, 4, get something like this. Q equals to 1, 2, 3, 4. At this particular endpoint, this is a GC endpoint. You can test for SQL injection by adding the hyphen over here. You can test it by maybe someone told me a few weeks ago that you can maybe say 2 plus 2. If it the URL, it gets 4. That's a UC endpoint. Try out the bypasses, try out the tricks. There is a SQL injection over there. You can test for server-side template injection at this particular point. Our next vulnerability, cross-site scripting, we talked about is HTML injection. Let's talk about cross-origin resource sharing. So our target, let's take this one, the repeater. We play with it. 3 or 4 bad. Check out 200 endpoint, check out 200 response endpoint. No, it's bad it this here. Oh, it's faster. So let's check for cross-origin resource sharing. We come, okay, let's generate our payload. You need a payload, That's origin. HTTP. Yes, or HTTP. info.com. Yeah. So we selected it, we copy, go back to our repeater, send the request. So our response is 200. Assuming that we haven't had a look at this response, so we add our origin here. We test for cross origin resource sharing. whether it is whether the trusted origins are whitelisted or not, because some developers they use an asterisk, which means that the application trusts any kind of application, which can lead to different classified attacks. So at the endpoints are payload, origin, send the request, and I can observe at the response. At this particular endpoint, we should have something like allow something true. Alright, this is not vulnerable to cross origin source sharing, but this is the same way to test it. At a particular target, at a particular pen test for bug hunters, that's the simplest way to test for cross origin source sharing. It's a P5, it's a P4, depending on the program. Can earn some bounty by testing this vulnerability. So our next vulnerability, let's have a look. I think I will have several vulnerabilities at this endpoint. We can test for a vulnerability named as Tabnabbing. Alright, maybe at this let's assume because assuming it bad, maybe for learning. This is architecture. Assuming, let's say these are profiles of the employers of this particular company. We have Stena here. We have let's say someone else here. Let's say person one. Okay, Stena, Alvin, the shield and stuff. So for Stena, this is his Twitter URL or his portfolio. Let's say the portfolio. So when one clicks this portfolio, by clicking, I mean not opening the next menu, it takes him to his portfolio. So you can inspect the source code, then go to the console, try the payloads, say opener location, and https evo.com. Okay, I'm going to use evo.com for demonstration, so that at each particular endpoint, when I mention evo.com, means we are at the endpoint of attacking. So evo.com, this is not vulnerable. Okay, assuming this was vulnerable, so what we could see at this particular home page is that the home page will automatically load the google.com, or it will automatically load evo.com by not being clicked that. So that's what we call a Tabnabbing. You can have a research later on. But our next vulnerability, let's have a look. Our next vulnerability maybe can be self-cross-site scripting, which is a P5. I think our next vulnerability for pentesters, I think we can talk about it. For pentesters, this is not a vulnerability, but for pentesters, you can highlight it, maybe an old copyright. Let's go back. Our next step is to register and check for registration and sign up page vulnerabilities. Immediately, let's register, get started. Close this, close. Well, let's register. Something's getting crazy. Wow, let's go in. So a unit ID allows you to buy and stuff depending on your target. So let's create a unit ID. By creating a unit ID, this means that we are registering at these endpoints. Let's create a unit ID. Create a unit ID. Let's create a unique ID. Okay, some pages say sign up, others maybe get started, and many terms, synonyms. Let's call them synonyms. Something is slow, someone is slow. Anyway, let's have some look for another vulnerability as it keeps loading. We talked about WebSocket hijacking, WebSocket vulnerabilities. We have WebSocket cross-site scripting that pops up on the server. Wow, those are the social media links. It's not bad to check. Let's check them. Let's check them. Facebook, Instagram, YouTube. Well, this is not successful. These guys have a Twitter. They have Facebook. They have, I think it needs a login. I think okay, check their own. For their YouTube channel, let's have a look. Not bad. As this keeps loading. Waiting time, otherwise someone is slow. Okay, they got a YouTube channel. So we are down by one vulnerability, but that does not mean that it's our first opinion. Okay, let's keep on the registration sign up page. You're gonna test for HTML injection, email verification bypass, rate limiting vulnerabilities, IDOR response manipulation, SQL injection, that's injection flows. So let's have a look. Yeah, here we go. Right? Yeah, let's do it. So immediately on the sign up page, on the email, I forgot a vulnerability. We call it weak password policy. Okay, talking of weak password policy, this is an endpointer that allows users maybe to create a username. Say the username will be the shield. Then on the password, it allows users to create quick passwords such as 1, 2, 3, 4, ABCD, 1, 2, AB, 1, 2, AB, maybe B, maybe DCBA. Okay, those simple passwords. That's what we call a weak password policy. Let's sign up. We're gonna test for our Gmail. It's gonna be the shell BugBounty at gmail.com. Yep, at gmail.com. Then you will receive. Okay, let's check this. Something interesting, right? Yeah, you will receive a confirmation email on this address. What does it mean? If we don't receive the confirmation email on this address, we're gonna go ahead and report the vulnerability, right? Yeah, let's do it. Then talk about the username. Say the shield. Yeah. Password. It's wrong. Username already exists. Okay, so this guy can see you. The shield. See. Exists. One. Wow. This one does not exist. For the passwords, let's try 1, 2, 3. These are the password requirements: minimum of 8 characters, maximum of 72 characters, at least 1 uppercase character, at least 1 lowercase character, at least 1 number. So let's try. 1, 2, 3. Okay, let's simulate where you can have a look. You have a 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a weak password. It's copied. Just here. Let's use it. Let's use it. Oh, it's a full name. Say a full name. Let's say the shield. Yeah. Then I'm a robot. Oh no, I'm not a robot. Select bots. 1, about something else. I think it's good. Oh, I'm a robot. I'm a robot. I'm a robot. I've read. Okay, at this particular endpointer, if a particular user can sign in by not acknowledging these terms and conditions, it can be a vulnerability still. Let's create a Unity ID. Remember, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 over there. Okay, you can see, but it's not recommended. Don't try at home auto-saving passwords. Okay. You can see a red line, meaning it's a weak password. Let's craft a strong password immediately to save time. We have the shield there. Let's see. Okay. This. Okay. At shield. Okay. We like something, right? Yeah. So there, 1, 2. I've used both characters, uppercase, lowercase, and stuff. Password, strong password. We crack it. In the game. Back down here, not bad, so I'm not a robot. Boundaries, what's about? Gories. Let's register. Okay. We are drafting our draft behind the scenes. We can get a look. Okay, robots.txt. I think you know the usage of this endpoint. Maybe sometimes it's good to have a look at robots.txt because you can get a sensitive information disclosure vulnerability, which can earn you some bounty and stuff. Well, it's a lot of hell of stuff. You can check there on. We are trafficking our data here. So you can, well, I have noticed something. We are using a port 2, which is not bad, but for authentication and question. Well, let's do this. Confirm your email. Can we? Yeah, let's do it. Start email. Start. Oh, what can you see? I can see something. Okay, we have a verification email, which is for Unity Technologies. The shield. Yeah, the shield. Thank you for creating a Unity ID. Click the link below to confirm your email. The link will expire in 15 days. Oh, bad luck. I mean, it will be something like 15, let's say 1 minute, so that I can be able to test for the non-expiration vulnerability and stuff. But I mean, let's do it. Let's take out to bypass this. Okay, at this particular endpoint, approaching our target, we can try email verification bypass techniques. How can you achieve this? For you to achieve an email verification bypass, it can be achieved by, let's say, response manipulation, right? Whereby when registering user and your intercept should be on, should be dropping and forwarding the request until a point when let's assume this is our endpoint that has the email verification endpoint sending. So we can say something like do intercept response to this request. Yep. So when you send it, okay, let's intercept this. This request. When you send it, you get the post request. I mean, not yet. We lost it. Let's do something. Let's intercept some request here. Let's intercept this one for robots. It's going to be interesting. Let's check for something else behind the scenes. Let's intercept this. Okay, I'm showing you how to do something, the vulnerability called via response manipulation, via response manipulation, right? Yeah. So we started. Okay. So we drop, 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 drop. Wow. This is our endpoint. Presuming this is the endpoint for email verification, how can we achieve this by bypassing it? So we do intercept the response to this request, forward, forward, forward. Okay. Well, so this is the response. Presuming at this particular endpoint, we get 4, 3, something like that. Then some stuff down here may be unsuccessful. You can come change here, it becomes 200. Okay. Then why it's false, you change to true. Why it's 0, you give it a 1. 1 meaning that's true, 0 meaning false. Then you forward. By doing that, you could have achieved what you call email verification by bypass via response manipulation. So back to our target, you can let's do the verification. Okay. Confirm. Can confirm, but I think at this particular endpoint we have done verification, so we can sign in. Something is incorrect. Something is incorrect. Some password of it. Wow, we are in. So for the registration, you can test for we are able to test for HTML injections, whereby we create payloads like this. That's that payloads method. Okay, payloads like okay, you must be an HTML programmer to achieve this HTML injection. Okay, HTML programming and stuff. So the shield. Okay, your name, and feed it in to that name registration endpoint. If it reflects on the other endpoint by being in bold H1, I think we both understand by the meaning of H1. That's a heading, the largest heading in the web page. So that's what we call HTML injection. And then rate limiting vulnerabilities. I think let us test for rate done this. Okay, rate limiting vulnerabilities. So immediately the proxy, we send something straight. Get some good endpoint, object, okay. Let's select this, send the intruder. Maybe you can do at a particular endpoint. Let's select this. Okay, this right here. Then I'll go to payloads. Say payloads 1 numbers from 0 to give it 100. But you can give it maybe 1,000 and depending on the program. Step 1. So 101 payloads, construct an attack. At a particular endpoint, let's say, presuming this lacks the rate limiting vulnerability, that can lead to what you call brute forcing vulnerabilities and stuff. So if you get 429, not 200, that's 429, meaning that the application has a rate limiting factor. So you can send data the repeater. At the repeater, try what you call rate limiting bypass. You get an X forwarded error here. X forwarded 4. X forwarded 4. And here, let's give it 127.0.0.1. What we're gonna do, we're gonna try to achieve what we call rate limiting bypass. It's a vulnerability, can be a bit trick. That's it. If you used to get a fault return error, then you add this, bypass the rate limiting. That's a good proof of concept. You can send it, get your bounty. That's okay. Our next vulnerability that we have to check is OS command injection. Okay, let's check for OS command injection at this particular endpoint. The profile update, nothing bad. Set time. Right, forgot password and get password vulnerabilities. I think I can check this as the last vulnerability, the last section for vulnerabilities. So at the moment, we're gonna tag the profile update immediately. So we're gonna jump to our profile update. It's our profile, right? Yeah. Our name is Stena. Our name is the shield, username, email, location, as you can see, time zone, and stuff. Our first vulnerability, the first vulnerability that I'm gonna check. Okay, you're gonna check for cross-site request forgery. If it lacks cross-site request forgery tokens and cross-site request forgery tokens, you're gonna try to check for this vulnerability. How do you check it? You come at this endpoint. Let's say you're gonna try to change the username. Let's get this one. Let's get this one. Big boys. Let's get this one. Yeah. Bye. Okay. Let's try to change this. So the shield 254. Gonna say drop. Something's going to work. Do we have YouTube? No, but why? Anyway. Yeah, Zeta. So this is a particular endpoint whereby we are changing the username. So the shield 254 down here. If it lacks anti-cross-site request forgery tokens and maybe the cookies. Some developers can use cookies to prevent cross-site request forgery vulnerabilities. So you can have a look at the cookie. Maybe it's a session ID alone. Let's say cookie this one, then some particular session ID here. That means that it's still vulnerable, but for our particular endpoint, it's not vulnerable. Using BugBounty Pro, assuming it's vulnerable, we log this cookie. Some junk. Yeah. This one ID session ID. Yeah. So if our endpoint was there at this particular character, so what we're gonna do, we're gonna generate a cross-site request forgery. You see, zip, then copy the HTML. Okay, pardon. Do this, then generate. Copy the HTML. Faster, save time. Here we go. So at this particular endpoint, let's try let's check for username. Can be here. So you can generate yourself a POC to perform this particular cross-site request forgery. So you get change this and say the attacker 54. Then you can save this particular to this particular POC. Save it to documents. Yeah. So let's call it cross-site request forgery.html. So we open our self documents. Then as a POC, you can open it using Firefox. Okay, Chrome one. Then you submit the request. For endpoint, Unity has prevention measures. This is because, as you can see, the change you wanted was rejected, so we were prevented by performing the cross-site request forgery attack. That's a talking of cross-site request forgery. I'm gonna drop this. Going back to our particular talk about server-side request forgery in the link addition functionality. I'm gonna explain this because time. So assuming that our whiteboard at your registration border, sorry, your registration board. Well, so your registration board. Then instead of maybe let's say at some point here, we have this thing we call your website link. Your website link. It is at this particular endpoint. On your personal information. So what you do, you can come to you get your external server. Let's say you're gonna use BugBounty. Yeah. So and generate your payload. Okay. Instead of you saving your website link, you can get your payload and save it there. If it saves and you can at some particular point you come back to here and for now, then you get an external interaction. Then that can be a good sign of blind server-side request forgery among us. Okay, it can also be referred to external service interaction. Depending on the impact, you can be able to turn into real server-side request forgery. It can be a P1, P2, depending. That's what we call blind server-side request forgery in the additional link functionality. Tabnabbing, we talked about is, let's say, presuming that, let's go to background. Yeah, can we? Yeah, let's do it. Background.com. Background.com. Can log in. Have a new account at background.com. Yeah, let's say profile. Let's say profile. So we visited the profile. It's a practical demonstration. Initially last year, some researcher at maybe hacker found a vulnerability at a background that was Tabnabbing. You could click the URL. The URL could open on the external endpoint. Maybe a new tab. So at this new tab, so you could come here, inspect the code source, so you need the opener dot location, say evo.com, Okay, for this particular endpoint, it's not vulnerable. But if we could be able to save it at this particular endpoint, then automatically this could reload to evo.com, making it Tabnabbing, which can be changed to do some impacts such as social engineering, phishing, and the rest. Well, let's save time. For voice command injection, let's try to change our. I'm selecting something. Let's try to change our email. Close this, speed, open this. Let's try to change our email. Back here, our email. Okay, this is one of the functionalities that you can test for. Let's try to change our email. Okay, not yet. mean, come on. Yeah. Oh, yeah, this is it. Let's try to change our email. Let's remove this bounty with the bug@gmail.com. Then I can intercept this. So save it. It's a post request. So our email down here, it is this one with the repeater for further surgery, because we are doctors. So at this particular endpoint, it's our Gmail, the shield bug@gmail.com. Okay, you can test for voice command injection using different payloads. Payload for tonight gonna be whom am I? Whom am I? So it's our payload. Come, paste it over here. Right, send it. Check the response. Whom am I? Okay, something not interesting. Okay, you can go ahead and encode this particular character as the URL, which is percentage 7C. By way. Oh yeah, the repeater. It's percentage 7C. That's a percentage 7C. I mean, percentage 7C. Yeah, that's it. I can send it. Amongst many other techniques, for those of us who are fans of remote code execution, it's another vulnerability that can be tested over here. Call it remote code execution. I usually use one payload for testing stuff. That's a percentage 7C echo star. Payload. I'm gonna test. So this particular endpoint, this particular payload, you can test it anywhere. You can come here, edit the cookie. Here, you can check it, observe the response, because this is where we can get demands, where we can get the vulnerability. Oh, and the rest. Our next vulnerability, because of time, cross-site scripting we have tested. Unrestricted test for file upload vulnerabilities, because they are key. It's a key vulnerabilities here. So proxy drop this and this. So my account. We're gonna test for file upload functionalities. That's where you can get the remote code execution. You can upload the shell and many other vulnerabilities. So our page here, we're gonna edit avatar, meaning we're gonna edit our profile photo. Immediately we're gonna just open this. We're gonna upload a photo. Open this. Go back pictures. See it. Oh, it's not. So we open this. That's mine. So we can confirm. Back to our repeater and have a look for the responses. Drop this, drop that, drop this. Can you see something? Yeah. It's a endpoint to uploading the avatar, the profile picture. So we can send this one to the repeater for further surgery. Close the scope, and you see, wow, this is not okay. Most web applications have the file upload functionalities as this one. Whereby when you upload the image, you get something like this. Maybe we have the normal request, then our content disposition, the file name. This is what the use endpoint is. At such a particular endpoint, you can test for SQL injection vulnerability, injection flows. You can upload, you can create a payload for cross-site scripting in form of SVG and upload it, and then maybe click if it pops up. That's a good vulnerability. That's a P3P2. At the same time, you can come here and upload the shell for file upload functionalities. So maybe let's say if you are using a PHP, if the web application, you can check for using Operator. You can check if it runs PHP. You go back, create PHP web shell uploads. Let's say something like exploit. Yeah, exploit.php. Okay, you can change even the name at this particular endpoint. Then edit the stuff down here. Yeah, like this. Then okay, this one profession. Yeah, profession. Well, it looks like this. Then you can send the request. If the request becomes successful with this exploit.php instead of exploit.png, instead of exploit.gpg, that means that we have our faster vulnerability at the file upload functionality, which is unrestricted file upload. So some programs can pay for unrestricted file upload itself, but we're gonna do it as big boys, as big girls. I mean, you get it. So we send the exploit.php to get some requests for further investigation. Copy this. Okay, you should assume a good scientist, a good hacker must be able to assume when learning. I mean, yeah. So it's a request. We uploaded the exploit.php web shell. So we're gonna confirm its presence. So get ourselves a get requester. Then we try to get our exploit.php. This is something like over here. Exploit.php must be unity.com. Okay, say target.com. You send the get request. If the get requester brings you the exploit.php that you uploaded, that means that your web application, your target is vulnerable to unrestricted file upload. Number one. Number two, you are able to upload a web shell. You can achieve by that particular endpoint. You could have achieved what you call remote code execution. You can change this unrestricted functionality, unrestricted file upload vulnerability to another vulnerability that's a pure critical vulnerability named remote code execution. Let's say you can upload maybe an exploit.php. You can call it over here. Let's say by using this for etc password. Yeah, if you call it and it gives you the etc password, text, that means that it is vulnerable to unrestricted file upload, to local file inclusion. Maybe, yeah, local file inclusion. That's what we call many web applications use this. You can try different types of bypasses. Let's say if your web application can only accept what you call PNG, GPG. Let's try GPG. Okay, let's say PNG. PNGs are normal pics, screenshots, selfie, the course. I mean, oh yeah. Let's get back here. So if your web application allows only is it content type that's an image stroke GPG. So here let's use GPG. Yeah. So if it only allows the upload with GPG, how can we achieve this? We can achieve this. We can achieve the unrestricted file by uploading our object like this exploit.php.gpg. GPG. Oh, why? Because by sending this, and if we call it over here, yeah, we call it over here .php.gpg, and it gives us our uploaded function, uploaded maybe shell or something else. Let's say uploaded file. That means that we are able to upload our exploit.php payload, maybe a web shell, and we are able to call it. Meaning that's a vulnerability. It is vulnerable. Going back to our target, our particular target here, the developer is learned. The developer must be one of us. Okay, because we're intelligent, maybe. So here he learns this, and he has this, because everything here is encrypted in base 64, making it do this. So to get you have to decrypt this, because to get base 64 stuff, I can see we have a lot of stuff here. I don't know how can we select. Let's do this. Let's do this. Copy this. Copy it. Paste it somewhere. Somewhere safe. Somewhere safe. This safe. Right. Okay. Let's copy everything. And once more, we delete. And we paste our stuff here. Yeah. Let's close it. Wow, yeah. So at this particular endpoint, for us to achieve unrestricted file upload vulnerabilities, what we do, we have to encrypt our payloads in base 64. Also, we can do something like let's use something that's faster. Say, okay, base 64 online encoder. So I can encrypt something. Post and looks decoder. We want to encode. Oh, let's encode. Let's encode what can we encode? Can we do cross-site scripting? Yeah, let's do it. So script what script prompt one. I can try this. Yeah. So let's encode. So it's our encoded base 64 payload. This is because our target was had. I can say our target. You can say our target could allow an avatar with only base 64 stuff. So we had to do what we call base 64. Why doesn't seem interesting? It doesn't seem interesting. Really? Okay. Add request. Some look at this. Oh, can check something. We need some we need what we call opening closing brackets. Not brackets, this one. So let's say. Oh, we did it, right? Yeah. So we are going to upload a cross-site scripting payload that's encoded in base 64, which is here. Okay, maybe let me give you a simple trick of identifying base 64 endpoint. Maybe I think I can zoom. Yeah, nice one. Yeah, let's do it. This is it. When analyzing, for those of us who do maybe CTFs, I think we have a CTF on Saturday. I mean, nothing hard. So 3 equals, that's a base 64. Oh, we're done. Understood? Yeah. Okay, maybe I can repeat. So you have a string. with 2 equals endpoints. That's our base 64. I think I'm done. That was not our topic for today, our topic for another day. So we have uploaded our cross-site scripting. What do you call it? We call it cross-site scripting. Payload. Yeah. Come back here. We can restart. Okay. Blocks you can drop it. Okay, you can see something here, right? It's getting interesting. I think the last time I did this, I got something. So we can see something here, like it's almost an image. I can do it, but gonna arrest us. I'm zooming. There's something here. Here, it's almost a kind of an image, but what we did, we uploaded a cross-site scripting payload. So since we're gonna get something today, let's click it. If it pops up, final good. Oh, not interesting. Let's open it in a new tab. Oh, it's to be saved. Getting interesting. Okay. Open. Oh, it's a payload. Yeah, right. So, I mean, if you're a bug hunter, we have an endpoint that allows unrestricted file upload. But how can you achieve this? Because we are good at what you call remote code execution. I think you can achieve. You can get something here. So I tested. You can also test it later on. There about tell us you need a writer. I think let's try something. Can you upload a PDF? Let's try. Nothing bad. But we're gonna arrest us for try. So the only thing that's needed here is DPG that we have uploaded what you call a payload in form of DPG. At the same time, I think we can even upload a shell. Upload a PDF. Files. We have the big PDF. Something directly here. So it uploaded PDF. I'm seeing some kind of behavior here, but I can't understand because you can see here we have uploaded a PDF, but it doesn't reflect our endpoint. But we have the first vulnerability and restricted file upload. We're gonna change it there on. Because of time, let's do some more hacking. Getting ghost. Is it? Yeah. So we have tested for unrestricted file upload for RCE and stuff. Okay, you can make an RCE payload by encoding it in an SVG. That upload and download and observe the difference. I mean, yeah. So let's test for forgot reset page vulnerabilities. I'm gonna start with base 64 vulnerability. Let's say that I saw some guy that got a bounty 2 days ago because of this vulnerability. What the guy did? The guy did this 64. Okay. He did this. Let's log out. You can test for logout vulnerabilities, cross-site logout, cross-site request forgery, amongst many other vulnerabilities. So this guy went to the forgot password. The email he used BugBounty at gmail.com. Okay, you can intercept this and try for the vulnerability we call voice command injection among many other injection vulnerabilities. So let's restart this and get the site link and have a look. So our reset link is here. You can have a look. Copy link. Have a look at it. No, you can't do this. Let's undo. I'm going to mode here. This. You can analyze the link. And since what we get here, we don't get something interesting. Okay, for that guy, what he got this HTTPS at the set link. So let's copy this. Here set password. Yeah, got this. And I'll see here. And then some stuff encoded in the 64. So when the guy went ahead and coded this junky stuff here, he found nothing else but something very easy. The reset link had this was the Gmail and encrypted in base 64 that was on this endpoint. Then the URL for the application. The guy reported got some bounty. I think it was around $200. Alright, next vulnerability. Next vulnerability, you can test for account takeover bugs. Here you can use maybe what you call response manipulation, amongst many other techniques for account takeover vulnerabilities, terms of voice command injection and server-side request forgery. I think it's time that we open for questions. Any question or add up on reduction? Yeah, the session is being recorded. It will be available in our YouTube channel. I'll share the link in our chat box most immediate. Any questions? How can I get the video? Well, I'm sharing the link to our YouTube channel. The session will be uploaded there, So that's our channel. Check the chat box. That's our channel. Okay, at the same time, if you want to join the WhatsApp group, I can share the link for the WhatsApp group. For more updates. Well, any question? What addition can I limit your mic? Someone suggested that we could have done how to write how to do maybe what you call BugBounty reports writing, article writing and stuff, but we'll plan it maybe next week. Any questions allowed?
I'm asking if was the meeting recorded?
Welcome, Duncan. Okay, the meeting is recorded and it will be available in the YouTube channel. That the link is in the chat box. You can have a look. No question.
Vamos.